In 5G, the core must radically change.
Automation has been one of the key trends in the telecom sector in recent years, and the drive by network operators to automate an increasing number of processes has only increased as they have advanced their 5G strategies and become more cloud-oriented. This drive for automation is impacting all parts of an operator's architecture, from the back office to the core to transport and the edge and access segments. So, how can operators hit their automation goals? To find out more, I'm talking with Bryan Davies, Cloud and Network Services Core Network Portfolio Marketing at Nokia. So, Bryan, with all that said, why is Nokia so strongly focusing right now on service provider network automation?
Well, thanks, Ray. Service providers today are looking at what web-scale companies have done in terms of closed-loop automation, and frankly, they want that for their networks as well. What they can do with that is maybe achieve a vision of having the network manage its own upgrades, having the network resize itself in real time, being able to deliver new services to their customers quickly and easily, and being able to have the network predict and find faults and fix them before they even impact any users. So the benefits to this are very, very obvious. From an operational efficiency perspective, they can reduce their costs with zero-touch lifecycle management. They can also achieve real-time optimization or network elasticity. From a business perspective, they can diversify their business through the acceleration of new services launches, as well as the introduction of service agility, being able to deliver a lot of more diverse services with the network. And finally, being able to achieve service stability that's even better than carrier grade is today through the use of the massive redundancy that's inherent in the cloud, and also by removing the humans out of some of the operational functions, therefore reducing the likelihood of human error. But there's a catch here. The catch is that it requires the entire industry to undergo a pretty major paradigm change. And that paradigm shift is essentially stopping thinking of the network like a telco and starting to think of the network like a web scale company.
And so what, in Nokia's view, are the main industry drivers for automation?
Well, there's three main contexts. The first is 5G and what it brings to service providers. The second is the history of automation in service provider networks. And finally, the third context is the telco cloud itself. So let's first talk about the 5G context. 5G brings with it many amazing possibilities and many more services that can be delivered much faster than they were before. However, to be able to support that, the delivery of those services and the launch is going to have automation associated with it. However, another thing that 5G brings is more complexity to the network. There's complexity as a result of geographically distributing the network out to edge clouds, and additional complexity that comes from network slicing, because you're adding networks essentially layered on top of one another, each with different SLAs. Automation will be required to manage the complexity in both of these cases. And finally, another aspect of 5G is that traditional services, voice, text, and mobile data, are all going to play a smaller role in the carrier's business. And what that means is they'll have less revenue, and accordingly, automation should be used to reduce the operational costs. So the key takeaway here is that automation really is required to gain the full potential of 5G. Now, the second industry context is what's been happening with automation regarding service providers over time. Automation is not new. We've been doing it for at least 40 years. The way that we've approached it is by looking at the fact that there's a network element, layering an EMS on top of that, and then creating automation scripts, which are essentially canned sets of instructions for the EMS to perform on the network element. The natural effect of this is to create disconnected silos or islands of automation. In fact, you have to ask the question, why have web-scale companies been so successful at closed-loop automation in such a short time, literally less than 10 years? when CSPs have not been so successful in 40 years? And the quick answer to that is that web-scale companies don't use network element-centric approaches. The third major industry context is the journey that telco software has undergone in moving to the cloud. As I'm certain you know, we originally started off with discrete network elements. And then our first attempt to cloudify those was to put those into virtual machines. We literally took the software and tried to stuff it into a VM. Not only did that not gain the benefits we were hoping that it would, but it even made performance worse. So it wasn't actually an improvement. So at that point, we got a little more clever. We decomposed the software a little bit into virtual network functions, and then created a management architecture around that called ETSI NFV Mano. So this is network functions virtualization. Now, this achieved some of the benefits of flexibility, but it didn't get the same automation benefits that web scales enjoy. But what's happening now is that we're moving to cloud native network functions, or CNFs. Essentially what we're doing is we're taking the telecom software, decomposing it at a finely granular level, and then putting them into microservices that are dataless and stateless and that live within CNFs. So that is the idea of moving onto a true web scale approach for network software. We're starting to see the benefits of this. And in fact, these three different market contexts, 5G, the automation journey that carriers have undergone, as well as the telco cloud transformation of software, these three things form a strong basis for the industry to have a close look at network automation. So let me explain a little about what that web scale approach would actually look like for a telecom application. Essentially, the web scale approach is to create layers of software, and each layer presents an as-a-service API to the layer above it, so that the layer above it doesn't have to worry about the fundamental functions of the layer below. So what I'm showing here is the cloud platform. This forms the infrastructure as a service layer, consisting of the physical hardware and the cloud infrastructure. Above that, we layer a web scale foundation. So this is where Kubernetes and Helm charts and things like that live. It's the container portion of the network that essentially forms a containers as a service layer. And that means the layer above that doesn't have to worry about container management. Above that, we start to get to telco-specific functions. And here what we're showing is a telco foundation layer. This takes common functions like database and message buses and implements those only once so that the telco application doesn't have to re-implement that on a per container, or even worse, per microservice, actually anti-cloud native to do that. Instead, that's actually encapsulated in this telco foundation layer. This is creating a platform as a service for the business logic, which lives above on the top layer. Now, the business logic is composed of CNFs that are composed of microservices. It's very important that these microservices are true cloud native microservices. That means they're dataless and they're stateless and they live in containers. That's key. It's also important that they expose APIs to the service orchestration layer above it. And what this does is this completely breaks apart the silos and allows the service provider to implement a carrier network using a true web scale approach.
Now, you mentioned earlier that service providers need to perform a paradigm shift. What exactly is this shift that they need to make?
It's actually a really key point of what we're talking about. The paradigm shift is essentially moving from telco thinking, which is thinking of a network in terms of network elements, and of course their associated EMSs, and then scripts of automation that reside on those, and moving really to a cloud-first approach. What's extremely important to realize is that this turns telecom completely on its head. The approach is essentially the reverse of what telecom has done in the past. The traditional telecom approach is we design a network function, and then we design an EMS to control that network element that embodies that network function. And then we put automation as a layer on top of that. But that's not what web scales do at all. The web scale approach is to design operations and automation built in from the start as part of the platform. It's there before the application is ever created. The application natively and intrinsically assumes it's there, and it's designed to take advantage of that. Can you see the difference there? The application doesn't exist before the automation does. The automation exists before the application does. What that does is that means that every application uses the same automation framework. This removes the silos that are causing barriers to being able to achieve closed-loop automation for telecom carriers. Now, long-term, this has some pretty significant implications for network architecture. The first is that network elements and EMSs will eventually go away altogether. They'll all turn into microservices. In fact, microservices will be everything. The core network functions will be microservices that are at a peer level to the operations microservices and even the back office business microservices. This will take years to happen, but that's the direction the industry is going in. And it's also the next big technology change that's facing the telecom industry altogether.
So if carriers are able to change their way of thinking about networks, what kind of network automation might this enable?
We've actually found that it's the best way to think about automation, especially when you're talking about core networks, is to envision use cases that use that. Part of the reason for that is that the core network itself doesn't do the automation. It needs to be automatable. And so we've actually fleshed out 5 use cases here to look at. The first is automated network updates. So this is the idea of a network update or a network function being updated and have that applied automatically in the carrier's network. Essentially, this is CI/CD. This particular use case in our explanation of it strongly talks about DevOps, but more than that, it talks about a Nokia service called DelOps, which extends DevOps to be able to take the DevOps concept into a carrier environment. The second use case is automated configuration and customization. Now, what you may or may not know is that when a vendor provides an update to their customer or a new network element, there has to be a lot of configuration that needs to happen. That's usually done manually. There also needs to be customization because every carrier's environment and network is different, which means that the vendor has to accommodate that. So that configuration and customization is done usually manually on the network update. And then that's sent to the service provider who then has to test it and then also has to then apply it to the network. So there's a lot of manual labor on both sides of that transition. If you automate that, then what you can do is you can remove a lot of the human interaction from the picture. And this increases the reliability of the update process altogether, as well as reducing the total cost of ownership of the network for the customer. The third major use case is core network optimization, or elasticity. This is what we actually showcased as the main benefit of cloud way back years ago. We haven't really been able to achieve it because it really does require a web scale approach to do this. But core network optimization essentially is the idea of having the core network elastically expand or contract to meet the load that's offered to it. But the place that's happening is in the containers layer. So Kubernetes, in this case, is actually doing the addition of CNFs and microservices or the subtraction of them based on the load demand. So that's the kind of network optimization we're talking about here. The fourth use case is network healing. Now, this is not the network healing of 5 or 10 years ago, where if a network element fails, you have some really smart operation system that routes around it. It's not that at all. Essentially, what we're talking about here is because you've built your core architecture, your core network functions on top of a cloud-native infrastructure, and because that infrastructure contains the ability to automatically restore microservices when they fail, then what you can do is you can have it automatically take advantage of that capability, and you can fix problems on a very granular level before they turn into big problems. That increases the overall reliability of the network. Finally, the last one here is network slice creation and validation. So I have a saying where I can't talk about automation without talking about network slicing, and I can't talk about network slicing without talking about automation. And the reason for that is because the two are intricately linked. Network slicing adds so much complexity into the network operations that you absolutely have to be able to automate that. The best way to do that is to make that part of the overall web scale infrastructure approach, just like the core network would have to be. If you do a web search for Nokia Core Automation and look for a link titled Core Automation Nokia, this should in fact be at the top of your results, then you'll find these use cases in a 2-page format that completely explains them in much more detail than I can here. You'll also find a lot of other materials, and be sure to look out for an upcoming webinar that is about 5G core automation that Nokia will be hosting. You'll see that on our website and also on this same page towards the end of July.
So what is Nokia offering in this area for service providers?
It's important to note that Nokia is approaching automation from many different angles. Nearly every part of Nokia has an automation program in place. Now, this includes the core networks organizations as well as the operations organization. From the core network perspective, our 5G core has been re-architected from scratch to be completely cloud native. We also have a product called Nokia Container Services, which essentially implements that second layer of the cloud layers diagram that I showed earlier. We have a couple of services offers. CI/CD services does continuous integration, continuous deployment, and it's a services offer, so it works with the customer to be able to integrate that into their processes, as well as the service lifecycle automation, which is another services offer. From our operations folks, we've got the Nokia Network Operations Master, the Nokia Orchestration Center, and then the Nokia Assurance Center, which are 3 operation systems that help actually provide that automation. And then from our network infrastructure folks, we've got Network Services Platform, which is an automated platform to help create network slicing for 5G networks.
And do you have a customer case example you can share?
Yes, I do, actually. We're very proud of this. So our customer example that's doing exactly this is Dish Networks. What they're doing is they've truly adopted the web scale paradigm in their approach. Dish is building a greenfield 5G standalone network on a cloud native basis using Nokia 5G core running on Amazon Web Services. Now, this is very important. Their objective is to disrupt the market using cloud native closed loop automation. That makes them an important company to watch to see how this plays out. If you go to Nokia's press release page and search for Dish, you can see both the original selection announcement from September 2020, where Nokia was chosen for the 5G core, as well as a brand new press release that was just released regarding Nokia, Dish, and Amazon Web Services.
Okay, excellent example, Bryan, thanks. Do you have any final comments or notes regarding service provider core network automation?
Yes, I do. In fact, the way to think of it is that the telecom industry is on the edge of a new way to operate service provider networks. But it really does require an industry paradigm shift in how networks are built, and mainly in terms of changing the thinking from telco thinking to web scale thinking. Operations and automation have to be built in from the start, not as an afterthought. And in fact, trying to automate legacy telco architectures to try and make them automated is actually not likely to achieve any more success than it already has. Now, this paradigm shift in the industry is already happening. It's already starting to happen at least, but it's going to take several years. Once it does, though, service providers gain benefits that the web scale companies enjoy, such as being able to operate efficiently, being able to diversify their business, and being able to take advantage of the massive redundancy of the cloud to increase the reliability of their services. I'd also like to point out that Nokia has the products and the technology and the expertise to make that happen. We can deploy our core products as physical network functions or VNFs, virtual network functions, or CNFs. Whatever the actual customer needs. And what this means is that we can help the service provider wherever they are in their cloud journey and help them achieve the benefits that automation will bring.
Well, excellent. And as you said, Bryan, we're already starting to see examples of this kind of thinking and this kind of approach to next generation networks in the industry. It's been a fascinating walk through the automation examples that you've given today, Bryan. Thanks very much for joining us.
No, thank you very much, Ray.